In this video, you will learn how to measure liquid accurately and precisely using a graduated cylinder. There are many different labwares that we use in experiments, but not all of them are suitable to measure liquids accurately. While some labwares provide precise readings during experiments, others are used as vessels to store and transport liquids in use. Considering the fact that chemistry is all about accuracy, it is very important to use a labware that is designed and calibrated to measure liquid accurately and precisely. So before we start our main topic, let's have a quick look on the precision of some major lab glasswares. Beakers and flasks are vessels mainly used to store and mix solution or to carry out chemical reactions. There may have some volume marking on them, but those markings are not accurate. In fact, some of the beakers and flasks don't even have the graduated marking on their sides. So they are just used as containers. Burettes and pipettes are one of the most accurate lab glassware for measuring volumes. They are accurate because of their narrow design. Burettes are generally used in titration experiments where an accurate volume of liquid is needed for successful results. Pipettes, on the other hand, are generally used as media dispenser. This means that they help chemists to transfer liquids from one container to other container. Unlike beakers and Erlenmeyer flasks, graduated cylinders are specially designed to measure liquid volumes accurately and precisely. The precision of these cylinders depend on the size of graduations. Some cylinders have these graduations with 1 milliliter marking, and they are precise up to the 10th place. And some cylinders have zero point 0.1 milliliter marking, and they are precise up to 100th place. It is very important to use a labware that is designed and calibrated to measure liquid accurately and precisely. Before we get started, take a second and look at very closely at this picture and see what do you notice. What do you notice about the liquid? If you look closely, you will see that the water is curved. Normally, water will curve at the edges of the surface where the water touches the container. And this is because water molecules are more attracted to the glass than to each other. And there is a special name for this curve called meniscus. Meniscus is a curve at the top of the liquid as a result of surface tension and its adhesive forces to the wall of the container. To measure a volume of a liquid in a graduated cylinder, we need to read the level at the bottom of this meniscus from here. There are some liquids where the curve goes up. In this case, we read the top of the liquid or top of the meniscus. In the picture that I have here, you can see a meniscus can go up or down. It all depends on the type of the liquid, if the molecule of the liquid are more attracted to the outside material or to themselves. A concave meniscus, which is what you normally see, occurs when the molecules of the liquid are attracted to the wall of the container, and this occurs with water and a glass tube. Okay. A convex meniscus occurs when the molecule have a stronger attraction to each other than to the container, as with the mercury and glass. This example that I have here, we have mercury in this glass tube, and you can see that we have a convex meniscus. Some plastic cylinders are made out of material that water does not stick to, and you will see a flat surface like you can see in this plastic cup. In this case, you will not see any edges. You will get the volume of the liquid by reading the center of the liquid in the tube, which is the lowest vertical point of the liquid. So you can see this in this plastic cup, or if you have a graduated cylinder, You can see here that there is no concave or convex meniscus, and it is just a flat surface or flat layer. So how to read a graduated cylinder? When you're reading a graduated cylinder, it is very important that you always read at the eye level. If we see a liquid slightly above or slightly below, we may find a little shift in the meniscus and get inaccurate reading. So we should always place the graduated cylinder on the flat surface like table or a countertop. Our eyes should be at the level with the liquid. We might have to lower our head and then read the volume at the lowest point of the liquid. This makes sure that you are reading the numbers right across, not from the top where you can get some where you might get a lower reading, or not from the bottom where you may get a little higher reading. So the best way of reading is right at the liquid level. Okay. You can enhance another. Okay. Another tip is you can enhance the visibility of the meniscus by placing a paper behind the cylinder. This will help you read the reading. Let's do some practice. For that practice, get a sheet of scrap paper to write your answer to the practice problems that you will see in next 2 slides, and be sure to pause the video and write the answer on a paper and then play the video to check your answer. Okay. So what is the volume of the liquid in the graduate? You can pause the video, write your answer, and then come back and check your answer. Remember that the rule while taking measurement is that we always take one estimated digit, and this estimated digit is the last digit. The digit prior to the estimate is always a mark on the device. So this cylinder that you see, this cylinder has marks for every zero point 0.2 milliliter. You can see that here you have 6 milliliter, and then 6.2, 6.4, 6.6, 6.8, and then here you have 7 milliliter, and then so on. So every mark that we have is zero point 0.2 milliliter. And I can see that the liquid level is above 6.6 and below 6.8, right? So your reading from the device will be 6.6, and then you will take one estimated digit. So the reading that I will take here will be 6 is my from the device, and I think it is very slightly above from 6.6. So my estimate that I'm taking is 6.62, and the unit here is milliliter. In this reading, this 6.6 is my known from the marking on this cylinder, and point 0.02 is my estimate. And this estimate helps us determine the precision of this measuring device. I hope you also have the same answer when you wrote it on the scratch paper. Okay, here again, be sure to pause the video and write your answer on the paper, and then play the video to check your answer. Let's start taking reading with the first graduated cylinder. This first graduated cylinder has marks for every 1 milliliter. You can see you have 20 milliliter here, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. So each mark is 1 milliliter, not centimeter. So each mark is 1 milliliter, and I can see that the reading or the liquid that I have is slightly above 25 milliliter. So the reading from the device that I will take is 25 milliliter. And after this, I have to take one estimated digit. And since it is very slightly above 25, so my estimate is just zero point 0.1 milliliter. And again, in this reading, this 25 is my known from the device or from the cylinder, and zero point 0.1 is my estimate. Okay, so the next graduated cylinder that I have, it has the same marking as the first one. That is, each mark is worth 1 milliliter. The liquid level in this cylinder is above 36 and below 37 milliliter. So your reading from the device will be 36. And after that, you will be taking one estimate. And to me, it looks like right in the middle of 36 and 37. So my estimate here will be 36.5. 0.5 is my estimate, and 36 is my known number from the device. And if I look at the sig figs, this estimated digit is also significant number. So I'm getting 3 sig figs from here. I am getting 3 sig figs from here. Okay, and the precision that I am getting is up to 10th place from this cylinder, up to 10th place from this cylinder. And let's see what we get from this third cylinder. So the third cylinder has marks for every 0.1 milliliter. So this is your 5 milliliter, and after 5 we have 5.1, 5.2, 5.3, 5.4, 5.5, 6, 7, 8, and then you have 6 milliliter. So each line is, or each mark is zero point 0.1 milliliter. And I can see that the liquid level here is above 5.4 milliliter, and it is below 5.6. So here is 5, it is above 5.4 and below 5.5 milliliter. So the reading from the device that I will take will be 5.4, and this is my known number from the device. And after that, I will take one estimate. And to me, this liquid level is very, very close to this 5.5 marking. So my estimate will be like 0.08. So I have 5.4 from the device, and then this zero point 0.8 is my estimate. And the sig fig is 3 again from here, but the precision of this device is up to 100th place. Okay, so this graduated cylinder is more precise compared to the graduated cylinders that you have on the left. And all of okay. All of these measurements have certain number of sig figs or values that tells you about the precision of the measuring device. This estimated digit is also significant. It helps define the precision of the device being used. I hope this video helps you understand how to take the reading from a graduated cylinder.